Alright, so next we're going to be looking at a 3D problem. So let's recap. So far, we've been doing problems with 3D. You can draw your 3D like this. This is X, this is Y, and this is Z. Or you can draw like this. This is your X, this is your Y, or this is your Z. So it doesn't matter which way you want to draw it, as long as you understand what is the condition like. So far we have been defining forces coming out from, for example, an origin here. We label their angles. So this one is force to x-axis. This one is alpha. This one would be beta, and this one would be gamma, obviously. So now, take a look at this one. Take a look at this picture. Is it similar? Are we still using alpha, beta, and gamma? What do you think? How does it look like? So obviously, if you notice, it is no longer the force to the x-axis, which is this one, right? This one will be alpha, but now this is not the case anymore. And this one would be beta, which is not the case anymore. And obviously, not this one also. This one will be gamma. So it is slightly different. So we are no longer using this method, alpha, beta, gamma. No, we're not using that one. We are using slightly different method. So let's look at the problem. So we are having the same axis. This is X, this is Y, this is your Z. The force is this one. This is 750 Newton. So now we are having some sort of a plane. This is some sort of a plane. This one looks like a plane. This is a plane flat on the ground. And we are measuring the angles towards the plane. So that's the thing which is happening right now. All our angles, for example 45 degrees, is measured to the plane on the ground. So this plane lah, this flat plane, or this flat plane. So typically it's easier to do that. It's easier to measure forces towards a flat plane. So in order to solve something like this, you have to create an imaginary axis lah. For example, this is X. This is X, right? Maybe you want to give it this name is X prime, something like that. So 750, you want to bring it down here on the floor, on this plane. So this line, the force would be 750 cos 45 degrees. 750 cos 45 degrees. So we can find that out and then resolve in a lot of ways. So if you cannot really see this one, maybe you want to look at from this perspective. Let's say you're looking from here, you're looking like that. So you are going to see this axis in 2D. This one is X prime. This one is Z. This one is your force, 750 Newton. This one is your 45 degrees. That is what's happening. So Yeah, it's like you're changing the 3D into some sort of like 2D. So you have a force here on the plane lah, 750 cos 45. So you can define this one lah, fx prime is equivalent to 750 cos 45 degrees. So what is the value? (530.33). 530.3 Newton. This is fx prime. So it's on the floor. So now if you look at it from the top, let's say you are looking at it from the top here, you're going to be looking at this axis. Now this would be your fx prime. This is actually 530.3 Newton. This would be your y-axis. This would be your x-axis. This would be your negative y-axis. This is looking from the top. Now this is the one. This is looking from the top. Since you know this is 530 and you know there's an angle here, and the angle is 60 degrees, you can find out this one, fx. So fx, which is here, is 530.3 cos, one more time, cos 60 degrees. What is the value? Cos 60 degrees. 530.3 cos 60 degrees. 265.2. 265.2. So this is the fx value. How about fy? So fy you can deduct. Not deduct, deduce from this one. This is your fy, which is equivalent length to this one. So this is the same length as your fy. So what is the value of fy? Fy is equivalent to 530.3 sine 60 degrees. So from this 750 Newton, you need to break into three components, right? You need to break into I, J, K. So you have done yourself a favor by... So this is not finished yet. You have to solve this one first. I haven't write down. Okay, let's solve this one. 530.3 sine 60. You're gonna get 459 Newton. This is your fy. This is your fx. So since both of them are important, you might want to rectangle it. Finally, we can do fz. How to do fz? So this one, you have to remember, this one is actually solving this one. This one is the work that we do to solve this one. And finally, we want to do fz. So let us do fz. We are now looking at fz. So looking at fz, you can immediately look at this one. Yeah, you can immediately look at this one in order to solve for fz. If you look here, this is the z component, right? This is fz. So fz is similar length to this one. So this is basically fz. So fz, the value is, so f z is equivalent to 750 sine 45 degrees. What is the value? 750 sine 45, 530.3. Okay, 530.3 Newton. Is that okay? So yeah, that's cool. So this is the answer lah. So you have successfully broke down all the forces into three components: Fx, Fy, Fz. So now you have to join them together. Join them. Join and set positive or negative and also I, J, K correctly. So this is what we're doing right now lah. Fx, the value fx is this one. It's in this direction. This direction. So it is positive. So this will be the f resultant. The value is positive. So 265.2 I. How about Fy? Fy is going the other way around, right? This is positive. It's at the back here, negative y. So Fy, which is this one, it's a negative value, 459 Newton. So it's going to be J. And finally, Z is definitely a positive, so plus 530.3 K. So we have successfully converted them into proper vector values. So this is the final answer. So if you want to check, obviously, check. You can get resultant by finding the magnitude, fx squared plus fy squared plus fz squared and square root. So what is the value? Plug it in. 265.2 squared plus 459 squared plus 530.3 squared, and definitely don't forget to square root the whole thing. So what is the answer? Press your own calculator. 459 squared plus 530.3 squared, and don't forget to square root. You're gonna get something like 749.8 Newton, which is 750 Newton lah, as per this one. 750. So if you can do that, so you have managed to resolve them into vector components. Once you get everything done in vector, any operations is very easy. So moving on. This is another problem. Currently, let's analyze this one. This is your x, this is your y, this is your z. It's a 50-pound force. Again, you have to introduce an additional axis, and the axis is called y prime. 50 Newton is here. You have to put it on the floor. So if it's on the floor, it's gonna be called, if it's here, this one is going to be called Fy prime. What is the value? Just look at this. This is 45, right? This is 45 degrees. Fy prime you can immediately get lah, which is equivalent to 50 cos 45 degrees. So what is the value? You're gonna get t cos 45. 35.36. 35.36 Newton. Not Newton, pound. Never use these things, Never mind, LB. Pound. What else? Fy prime. So if you are still confused, you can convert into 2D. Convert 2D. How do you do that? You just imagine you have an eye on top here. This is your eyes, it's looking down. So when it looks down, you're going to see something like this. This is a y-axis. This is definitely x-axis. This is negative x. So this is actually Fy prime. Or how about the gradients? So the gradients is going to be like this, 3, 4, 5. These are the gradients. 3, 4, 5. Fy prime already solved. Way ahead of you. 35.4. Okay, this one . So Fy you can get it easily . This will be Fy. How about this one? This one. So actually, Fy is this value up until here. This is your Fy. This will be your Fx. But it is in the negative component since the other way around. So we can easily solve this. This value we know. So again, 50 pound ni, you got to convert them, right? You have to find I berapa, J berapa, K berapa. So you got to find them one by one . You might as well, never mind, we have Fy here. Solve Fy first. Fy is actually 35.4. Hypotenuse first. Hypotenuse is 5. We are looking at horizontal component, so this is 4. What is the value? Times 4 divided by 5. 28.3. 28.3. This value is J. And is it negative or positive? It's actually this one . So positive. Why x will be a negative value? So let's look at x. Fx is actually 35.4 over hypotenuse. Hypotenuse is 5. Look at the component. Component is vertical lah, so use 3. And it's already negative. So it's actually a negative lah here. This one is actually x. X will be I. So what do we get from here? 35.4 times 3 divided by 5. 21.24 negative 21.2 I. This is the answer for fx. This is fy. So both things are very important lah. So make sure you rectangle them, because we are going to use this again. Finally, we gotta look at z. So let's take a look at z. Again, if you are not confident with this one, you can draw something in 2D. So if you draw, you're going to see something like this. This will be your y prime. This will be your z value. This is your 50 pound. This is 45. So this one is very easy. This would be the component of your f z. This was solved before. This was fy prime. So fz is equivalent to 50 sine 45 degrees. Sine 45 degrees. So what is the value? 35.36. 35.36 or 35.4. What is the value? It's a positive z. So 35.4 K. So these are important lah. This is fz. So you've got all the components here. fx, fy, fz. Combine them together. So combine them lah. You're gonna get the correct answer lah. Negative 21.2, 28.3 and 35.4. Okay, you are correct. Again, it's a good idea for you to check. Are you doing a good job? So if you want to check, use this formula. Fx squared plus fy squared plus fz squared. Take out this I. So remember to square root. So fx 21.2 squared plus fy 28.3 squared plus fz 35.4 squared. Now square root. The value, what is the value? 21.2 squared plus 28.3 squared plus 35.4 squared square root 50.034. So you are correct. You have successfully resolved them into components lah, I, j and k. Okay, how about the next one? This is exercise 11. Do you want to do this yourself? I think you should do this yourself, huh? Try on your own, okay? Try this on your own. Maybe you want to discuss a bit. So, do this on your own. So, let's discuss a bit. So, pause the video. Alright, so I believe you have done this on your own. Now it's time to check. So you want to check your answer whether it's correct or not. Okay. Which one is easy? Yeah, now we have combined. If you look at this angle, this one, this is actually alpha. This is actually beta. And finally, this is actually gamma. So they have combined two types. Number one is your alpha, beta, gamma angles. The other one is the one with your fx prime and also probably fy prime, probably using the primes. Using an additional axis. This is probably going to be y prime. So there are two things lah. So you have to review back what have we done for alpha, beta and gamma, and what have we done for y primes. So let's start. Probably with something easy. So I guess it's going to be this one lah. I think this one is going to take a lot of work. This is going to be using fy prime. What is it? Okay, so let's start. Maybe we can use the space. Number one, we're gonna solve something easy first. Let's do. Okay, let's do f1 first. I'm gonna clear the old ink. Okay, let's start with f1. We need to convert to vector I, j, k. I, j, k, convert to vector. Again, this is your y prime. You're going to have components lah, this one. So y prime, what is the value for y prime? Fy prime is equivalent to 450 cos 45 degrees. Berapa? 318.2. Okay, this is your fy prime lah. Equals 318.2. So what is the fx value? So fx, you know lah. Do we have to draw the auxiliary axis? Maybe we don't. Maybe we do. So this is your fy prime. Fy is over here. So fy is equivalent to 318.2 cos 30 degrees. $275.6. So this one is actually j, positive j. Next. So we have solved one thing lah. So next will be fx, I guess. Let's do it over here. Fx is equivalent. So fx is at the back here. This is your fx. Obviously, it's going to be a negative. So 318.2 it will be the same distance as this one. So this fx. So what is it? So the value should be 318.2 sine 30 degrees. Sine 30 degrees. Negative 159.1, which is I lah. Negative 159.1 I. This is your fx. Finally, we should be looking at fz. This is the component for fz. Right? This is your fz. Fz is actually 450 sine 45 degrees. .318.2. Okay. So combine them all. F1, if you combine them all the components, and all the component is this one lah. This one, and also this one. Combining all of them, you are going to get F1 is equivalent to this one, negative 159.1 I plus 275.6 J plus 318.2 K. So this is what you get. This is your F1. So obviously, you need to solve for F2. F2, you need to find this additional angle, which is gamma, right? This is alpha, this is beta. Do you still remember the trigonometric identities? Cos squared alpha plus cos squared beta plus cos squared gamma is equivalent to 1. So, cos 45 degrees. Should I write again? Maybe not. Simplify things. Never mind, I'll write again. Cos 45. Cos squared 60 plus cos squared, don't know, is equivalent to 1. Zero 0.7071 squared plus cos 60. 0.5 squared plus, don't know cos squared gamma, don't know. This one you're gonna get 0.5. This one 0.25 plus cos squared gamma is equivalent to 1. cos squared gamma is equivalent to 1 minus 0.5. You get the point, right? All this you have to bring to the side lah. Bring to the right. So 1 minus 0.5 minus 0.25. So you're going to get 0.25. So remember, you have to square root on both sides. So once you've done that, you're going to get cos gamma is equivalent to 0.25. Cert 0.25 is equivalent to 0.5. So since it is square root, so you have positive value and minus. So solving this one, you're going to get two values lah. Gamma is going to be, what are the two possible value? Shift cos 0.5. It's either 60 degrees or shift cos negative 0.5. 60 or 120 degrees. So which one will it be? How do you decide? You need to look at the diagram. If you look at the diagram, you're going to see something like this. Right, you're going to see something like this. So this is origin. This is your y-axis. Going up is your z-axis. The force is actually like that. How much? 600 Newton. So, where are our angles? Our angle is very big. Definitely more than 90 degrees. So you have to choose 120 degrees. There's no other way. Choose this one. 120 degrees. So, if we finalize everything, you're gonna get F2 is equivalent to F cos alpha I plus F cos also beta j plus F cos again gamma k. This is what you should write. Okay, so now let's plug in. 600 cos alpha. What is alpha? 45 degrees I. 600 cos 60 degrees J plus 600 cos 120 degrees K. Again, let us solve this. 600 cos 45. 4 to 4. I'm going to simplify. 4 to 4 I plus 300J and 600 cos 120. You are going to get immediately negative 300. It's going to set for you correctly. This will be F2. So, the two things that you need to take care is the two important things lah. I'm going to put it in purple color. This was the first one which you have solved, and this is the second one. So in order to solve this properly, you need to solve resultant. F resultant will be equivalent to F1 plus F2. Yeah, F1 plus F2. So what are the values? So you have to add them properly. I component, you have to look at all your i's. J component, this is your J component, right? Add with your J component, add them together. And finally, K component, this is your K component, add with your K component, add everything up. So final answer, you're gonna get something like this lah. F resultant. What are the value? 424 minus 159. 265 300 plus 275. 576 lah. J. 318 minus 300k lah. So it's going to be plus 18.2k. This is the final most answer that you're going to get. Again, we got to check the resultant. Fr is equivalent to, what is the value? (265 squared plus 576 squared plus 18.2 squared, and remember always to square root. What is the value? Punch in your calculator. You are going to get exactly 634.3 degrees. Not degrees, right? Kilonewton? No, it's Newton. This is your resultant. So you are correct. And of course, you can find out what are the final angles and final alpha, beta, gamma and such lah. So this is the value. Okay, so that's all for this part lah. That's all for this part on forces with angles. Next topic will be something very, very easy.